Yeah, thanks everybody for coming. This is an awesome turnout. Is it cool if I go ahead? Yeah. Awesome. So there's a whole lot that I hope to cover today, so I'm going to jump right in. First, I want to talk about who am I? That's me, and I'm often seen holding a parasol. I work for Adobe, which if you're not from around here, you may have passed it driving down I-15 when you pass the point of the mountain. We have an office here for the Adobe Marketing Cloud, which is the other half of Adobe, from what most people are familiar with, the Creative Cloud. And on that team, I work on the web services side of things, which is basically overseeing all of our APIs that people use to interact with our platform. On top of that, I also maintain the API gateway, which is a fancy term that basically means a thin layer that we can use to interact with other services that are across our platform. And since we are rather large, there's acquisitions and there's services that exist in different data centers and whatnot. And so something that we've done is we've exposed a layer that handles tracking, logging, authentication, obviously, and that's part of why I'm doing this talk. And then, of course, we're hiring. So if anyone is interested in working with APIs, come talk to me after the talk. One more thing that you probably don't care about. It doesn't really impress my girlfriend either, but I'm pretty proud of it. I maintain and authored the #1 open source PHP library for server-side OAuth. So if you're a PHP developer, definitely check that out. And I'm in a band. So if you like folk music, I didn't bring any CDs, but yeah, check us out too. So, and one more thing before we begin. You can check out the Joined In. This presentation is on Joined In, and any feedback that you guys leave would be incredibly appreciated by me. It helps me not only get other talks, but also know how to make this talk better or how to be a better presenter in general. So that's on the Openwest schedule. You can link to it from there. So, yeah. What was the name of your band again? Oh, sweet. More Houses, More Heroes. I was debating if anyone would actually care, but glad I put it on there. It's perfect for that. So we're here to talk about OAuth and what OAuth can do for you. I hope to cover both the client side of things and the server side of things. It's probably impossible not to interact with OAuth in some way as a developer today, just because so many of the main APIs out there support it. And also, I hope to provide you with information so that whenever you are protecting your own APIs for whatever application, maybe big or small, you know what's out there and whether or not OAuth is a good fit. So to get started, we have a lot of heavy stuff today, but we'll start from the very basic level with a nice little tale on why OAuth exists in the first place. And it's called If You Give a Developer a Computer. So if you give a developer a computer, she'll want to build a website. And if she builds a website, she'll want to build APIs. And if she builds those APIs, apps will be built off those APIs. So mobile, tablets, desktop apps, what have you. And if her users start using these apps, they'll be prompted for their username and password to log into these apps. And if they enter their username and password, which of course they will do, her website will make the front page of CNET when all those passwords are stolen. The end. Hold your applause, please. So the moral of the story is don't require users to authenticate with third parties using passwords. And so this is the whole reason OAuth exists. This is why in 2007, Twitter decided to invest in creating this protocol. You had all these apps being built that weren't really maintained by Twitter, but that needed users' authorization in order to work, and they didn't want their users wantonly entering their passwords into these other people's apps. So to a lesser extent, also, OAuth doesn't want you to use passwords really, period, for using APIs. And we'll talk about that in a minute, but tokens is really, the key word and the real currency that's used whenever you're talking about OAuth. So this is maybe what you guys are thinking right now. This is kind of how I understood OAuth before really diving into it, which is, I know you use it with some of these services, Facebook, Twitter, maybe Google. Probably authorization and authentication happens somewhere, right, because of the name of it. There's a lot of tokens, and there's something about legs, multiple legs, I'm not really sure. So before we go any farther, we're just going to do a super quick technical overview, some of the key points of OAuth. So OAuth, if you remember nothing else, it's just a big set of rules that explain how two parties exchange tokens. We'll get into this more later, but obviously the optimum thing to take out of this is that the rules, there's not one way, right? There's multiple ways. That's the whole name of the talk, right? The currency is tokens, and usually you exchange some other type of currency for those tokens. May it be user credentials, signing of using a private key or something of that kind. But if there's not tokens in it, you're probably not talking about OAuth. Tokens expire. This isn't always true, but usually they do. And this is an attempt to limit the threat vector of, if tokens are compromised or whatever. This is pretty nice. It's kind of like a fail-safe. Basically, it allows for a lot of different types of I don't know. It's very useful in a lot of ways. For instance, if you have API services across the world, multiple data centers, whatever else, and they're all validating these tokens. If a user's account expires, if a user's credentials get compromised or whatever, you basically just need to cut off these credentials at the source, stop issuing tokens, and everything that's out there is just going to naturally expire. So you don't really have to worry for a long amount of time. This can also be a huge pain in the butt if you're a client and you're implementing tokens and whatnot. So, that's unfortunate. That's one of the main complaints of OAuth. Bearer tokens are a big deal. This is basically this isn't the only type of token you can have, but this is the main type that you see. And basically what this means is the person who has the token, aka the bearer, they have the same permission as anyone else who has the token. Said another way, there's no proof of ownership required. If you have a token, then you have a token. You can do whatever that token allows you to do. Okay, so the final thing, large, overview type thing I want to cover is just this idea of applications, which if you've ever used any of these, Facebook, if you've built apps to any of these things, Twitter, GitHub, Google, the first thing that you'll do is create an app, right? So this is a pretty key concept. An app is basically just a conceptual wrapper around a project, right? It's probably going to use a certain way of authorizing or making calls to this API, and it's basically a one-to-many relationship between a user and their projects. So a couple more things. There's three roles that we'll be talking about today. We have the user, which is the person whose data exists behind the APIs in some platform. You have the server, which is the platform, which is exposing the APIs. And you have the client, which is the third party. And this is something like I've mentioned earlier, the desktop apps that show your Twitter feed or whatever else that maybe aren't in connection with the server, but they might be. And also a lot of times these two things can be the same too. So for instance, you just want to access your data. Let's say you want to make an app that just grabs, your Facebook friends and shows them to you on your desktop. I don't know why you want to do that, but I didn't think of an example beforehand. So you would be the client and the user in that case, right? So when we talk about three legs, we're talking about these three parties: the user, the service, and the third party. Yeah, that was a Google image search gold mine right there. So, and also, sorry, I should have said this on the last slide, but when those two are combined, then you're talking about two-legged OAuth, right? And I'll go into that more later. But you also have three endpoints, and these correspond to the three the three legs as well. You have the authorize endpoint, which is basically the step in which the user grants access to their APIs. You have the token endpoint, and this is really the most important one that we'll see. This sucker always returns a token, always. You interact with it in different ways, but really between these two, things stay pretty consistent. This will return a token, and this will validate a token and give you back the data. So this is just the APIs, right? This is very generic. We call it a resource server or whatever else, but it's just the APIs. So this is probably the most complicated part of OAuth, so don't freak out. But the grant types are what kind of makes OAuth so cool, because it allows for the flexibility of the framework. Essentially, you have these are I've included the grant types that are included in the OAuth spec, the official spec. The real world looks very different, and we're going to cover a bunch of the different grant types that exist out there that I've seen anyway. And but this is really what makes OAuth so special, is that all grant type basically represents different ways to obtain an access token. So just like I was saying before about how the token server will always return a token as long as you interact with it in a valid way, the grant types are just, they define all the different ways that you can interact in order to receive an access token. So I already said that, but this is what makes OAuth the Swiss Army framework, which, in case you forgot, is the title of this talk. So that's what we'll focus on. Now, if you read the description of my talk, which I'm guessing most of you didn't, but I made the promise that OAuth is good for big apps, small apps, for 2 legs, for 3 legs, for the enterprise, for server-to calls, whatever. So that's what we're going to cover for most of the remainder of the time. And again, if anyone has any questions during any of this, just yell something out. That's totally cool. So one of the main criticisms is too hard. We're going to start on the easiest level, show you how to get a token in the easiest, most simple way, and then we'll go up from there. So once again, here are 3 endpoints that we discussed: authorize, token, and then the API call. And all these flows are going to map to this in some way. Now, the easy level of grant types that we're going to talk about first, none of them are going to even care about this top one. Because it's 2-legged, we don't need to authorize. We don't need a step where the user says that a client's allowed to access their data. And I hope that makes sense. But because we are the user and the client, you can completely get rid of that top step. So for the next couple grant types, we're just going to be talking about how to interact with this token server to get a token. So the first grant type, the easiest possible way, is this idea called a personal token, access token, which I've only seen in GitHub. It's not even really an official type, but I think it's worth mentioning because if you're exposing APIs on your server, you might want to do it this way. I think it's kind of cool. So basically what they have is a screen where you as a developer, you select the different things that you want this token to have permission to do, and this is called scope, and I'll mention that later as well. But it's very simple. It's just a string that says what that token has access to do. And you add a description for that token, and it will generate for you a one-time access token that it does not store, and it treats it basically like a password. It says, grab it now or you'll never see it again. I imagine they hash it in some way in their databases so that it's secure. And then it never expires. You can use that token to call their APIs from then on out. So it's not technically OAuth, but I think it's cool, right? It's easier than dirt for your developers who are interacting with your APIs. Super quick way to get started and just call the APIs on your behalf. Also, it gets users starting to use tokens, right? And this is important if you have other more advanced ways to go about getting tokens like GitHub does. So just real quick, once you get this token, I want to cover what this looks like. There's usually a couple ways that you can use this when you're making an API call. But here on the left, we have the raw curl request. And on the right, we have what this looks like, just an HTTP. So you can provide it as a authorization bearer in the header, which this is probably the most common way to expose the token. You just put in there in plain text, XYZ is the token string. In this example, you're adding it as a get parameter or a post parameter, depending on the the type of call you're making. And then in this example, which I've only seen in GitHub, but I thought it was interesting, they just put it in as a basic HTTP authentication. So this is like user password, but the password's empty. So it's very simple, right? And the documentation will cover this, but you essentially just pass the token in with the request. There's no nonces, there's no encryption, there's no timestamps, there's nothing. It's just a token. So, yes?
Is there a preferred way of taking that token in? Like, is any one of those three better than the other? Or more?
No, I don't. Usually there's a hierarchy to determine precedence, and the first one is header, the second one is post, and the third one is the get parameters. There's different use cases for why you would use each one. In general, I personally prefer the header. It seems more restful. But yeah, I couldn't really defend why. There's no real reason as far from a security standpoint. Okay, so that's it with that one. The next one is client credentials grant type. And this one I will try to go through super fast because I've never actually even seen this one out there. It's just in the OAuth spec. But I think it's interesting just academically. I kind of like the spec a lot. I hope that's not weird. But I wanted to tell you guys about it anyway. It's really quick. So basically, whenever you generate this application, and again, client is application. It's actually, I don't know if I'd explain that. But when you see something like in the Facebook UI that says create an application, another name for that is a client. And why that is, I can't really say. I think it's just when they wrote the spec, they wanted to be all technical, and they used the word client. So application usually used in the UI. I've never seen client used in a UI. But whenever you're reading technical documents, usually it's going to be client and not application. But basically, you get a set of client credentials when you create it, right? You've probably seen this in Facebook or whatever else. They'll give you a client ID and a client secret, and it's this 40-character string, and it's huge, and it's hashed, and whatever else. So client credentials is basically you use those to get a token, right? This is kind of useful because you hard code the credentials, but the credentials are specific for that particular call. So if it gets compromised, they can't really use it for anything else. It's kind of a nice, neat way to organize, your applications and your credentials. It's good for server-to-server calls. This is just me, brainstorming. I feel like it would be good for that because it's not necessarily tied to a user, right? It's just tied to this concept of your application. And the calls are implicitly associated somehow with the user or an application on the back end. So I'm spending too much time on this because it's not a very important one. But basically, you just plug in your credentials and you make the call, right? Sometimes I've seen it where you put it in the post body. And sometimes I've seen it where you put it in the basic HTTP header. So right here. And then just like we saw with the workflow before, this is made to some predefined token endpoint from the API, and they give you back the access token. So pretty basic stuff. Oh, yeah, and just a refresher, once you get the token, you stick it in your next request to the API, and it'll give you back the results of the call.
So you're saying this is mostly for if my app needs to be authenticated to access some public Facebook resource, for example, or something, I might want to use this strategy because it's just between the client without concern for a user behind it.
Right.
But I want to make a search, and public searches are limited to 1 per second, but authenticated searches are limited to 10 per second or something.
Yeah, no, that's actually a really good example. Okay. Another example is maybe it is associated with a user or an organization, but it's done when you configure the client. And so you could make calls to say /profile and get back your profile. You could never actually use it for another user's account, but it would always be associated because it is a two-legged approach. So yeah, you're either talking about a public API or you're talking about an API that when it receives your token, it knows who's making the call and can serve up the request accordingly.
We use the LP API.
What's that?
We use the LP API, YELP.
I don't know. I haven't. Oh, okay. So they have a similar flow to this. Awesome. Thank you. Okay. So this is the last of the easy stuff. And GitHub has this one as well. This is called Resource Owner Password Credentials. And if you can interpret all that jargon, technical jargon, you'll understand this is talking about just the user. So what this is a user and password combination. You call since it's two-legged, you just call the token endpoint with these credentials, and you'll receive a token for that user. So yes, this is equally difficult to dirt. It's very easy. It's also sometimes used if you have login forms on multiple platforms, and whatever the user enters in, you can just go ahead and send that off an API call and get a token back without ever storing their credentials. So it's not great, right? I mean, we'd rather do a flow that I'm going to talk about next, which is authorization code, in which the user actually gets redirected. They never actually send their credentials through the client, and that's the best case scenario. But this is actually good. Let's say the login form is a trusted application. So this is, you build your website, and then you build a developer resources website, and you want them to be able to log into both without being redirected around. You can reliably use this grant type because you're not going to store their passwords in plain text. So it's bad, though, because it encourages hard-coded credentials. If someone can use this grant type to send in to receive a token with their own username and password, maybe they'll just put that in their code, and then things work until they change their passwords and everything breaks. So this is typically it's not a very good one to use, but it exists, and it works about like you'd expect. You just put username and password into your request, and then you submit it to the token server. And the reason why I have the GitHub URL and path here is just because this is actually how theirs works. You don't need to specify a grant type. It's implied by the parameters, but according to the spec, you're supposed to do this. But it's really that simple. It's very easy. And if everything validates, you get an access token back. Awesome. So that's it for two-legged. That's it for the easy stuff. Does anyone have any questions before I go on? I know you had a question earlier. So. Cool. So authorization code. This is probably like the best. It's the greatest flow ever. Remember this guy. This is what he's all about. So authorization code is why OAuth exists. It's for authorizing a third party, and it was specifically built for web applications. So you may have seen this screen before. You've seen the screen 100 million times. This is authorization code. If you see this in your browser, that's what's happening. So how this works is you as a client get redirected somehow. It's probably a button that says, click here to authorize. Click here to authorize Facebook and get all your friends or whatever. And this is going to send you to a specific endpoint on the authorization server's domain. And as a result, they're going to display you the page that I just showed you. And given that you say yes, it's going to send you back to the client via some pre-arranged redirect URI. And all this is an endpoint on the client's application that's programmed to field these requests. And then once you land on that URI, the client behind the scenes is going to take something called an authorization code, which the authorized server included in the query string, and exchange this behind the scenes for, you guessed it, a token. And then the rest of this, hopefully, you already have down. So just to be explicit about what's happening, a GET request is issued to this authorization server where you'll be displayed an HTML form asking you to authorize whatever the client is doing. And if you consent, then you're going to be redirected back to the client with a code in tow. And this is the authorization code right there. That's the juicy stuff. And behind the scenes, then the client can go ahead and make this exchange. So that's pretty easy, I think. Right? OK, what's up? This one, got it.
No, the other one. So that request is made, if I'm using a browser, it's the browser that makes this request to that server.
Yeah, you as the end user actually initiate this request with clicking on a button. Yes.
Okay, and then that response, so the next one, that response sends them back to your server with that code, and then the browser isn't involved in the next part, right?
That's exactly right, yeah. And that's actually pretty important.
Is there a problem just doing this in the clear? HTTPS?
Oh, it better. Oh, yeah, that should be HTTPS. It actually, see, it's interesting though, if you make it HTTPS, you're just layering your security. This code alone is not useful to anyone unless they have client credentials. So something that I should have covered, and it still should be HTTPS. Don't get me wrong. All of this, any of this should be HTTPS, and if you're not doing it, shame on you. But this call right here, this is your client credentials. So your client credentials are used when you exchange this code, so it knows that the client making this call and exchanging this is the client that it's been issued for.
But if those are also sent to clear,
So
Yeah, then you're a big idiot. Yeah, don't do that.
the client in this case has the dual meaning of browser and server because the browser is making one connection, but the client password is not in the browser; it's on the server.
Yes. And some diagrams will have like this whole part here highlighted, and they'll say, browser. And then this part says server because they want to distinguish between where these calls are being made. So yeah, if I had more time, maybe I could do something like that next time.
On that topic, though, so OAuth1 always scared me because it was like cipher, decipher, decrypt, HMAC, and I was
Yep.
like, wow, that sounds scary. I don't even want to try to use that.
Yep.
It just sounds complicated, but it seems like OAuth2 doesn't have all of these same cipher, decipher.
Yeah, and that's a huge criticism that people use who are pro OAuth1, and some servers like Twitter supports both. There's a couple more that support both for that reason. The thing is, if it's over HTTPS, then it's considered secure, right? But your security is not layered. So let's say are you familiar with curl? You can make a request using curl with -k, which means don't validate the certificate. And that means that if anyone is sitting in between you and the HTTPS server, that call is no longer secure, right? They're just listening in, and you don't even validate it, so you go ahead and send the request. So that's a problem, right, for some people. For Google, for instance, and I'll show you a grant type in a second that Google uses to make sure that even if their users make insecure requests, they still can't be, replayed or used by an attacker. But yes, for all of the flows we've seen so far that use a token in the clear, if you're not validating the HTTPS certificate, if you're making them over HTTP, you're exposed. Does that make sense?
Well, I guess so, but how many eavesdropping devices are there between the server that's in New York on a rack and the one that's in San Francisco on a rack?
Just one, yeah. There's probably someone in here that can answer that. I have no idea, I'm just going by best practices here. And I should mention, I'm not a security expert by any means. And I follow this protocol as closely as possible. People at GitHub have taken huge liberties with this, and I imagine they probably know what they're doing. I don't know if I'd say I want to be, especially with Adobe in the last year. I'm not sure I want to be messing around with the spec. So I follow the spec very closely, and again, the whole expiration helps with that. If someone does eavesdrop, then it expires. So
originally, the user was sort of redirected to a page, put in his. I'm trying to remember where. So that basic right there. Wow. Okay.
So one thing I didn't mention here is that the user logs in.
User logs in, puts
Yeah.
in stuff there. Token comes back. Then there's this other password that was pre-stored somewhere in the server that gets put in that authorization.
Yes.
Is that what's going on?
Yeah, those are the client credentials. Let's see, I have a slide here.
That's the second leg.
Let's see. 1 second. This one. So this slide here, whenever you create an application, you are given a set of client credentials. And it's a step I didn't show explicitly because I assumed, and I shouldn't have done this, but that people have done this before and seen the screen where it says client, it'll say client ID. Each of these will have their own client ID and client secret.
And your client ID for Facebook is not your client ID for
Oh, no.
Twitter and all that. So that's why
Yeah, each of these will have their own client ID and client secret. And usually you can't pick either one. The only thing you can do is refresh them. So if you want to generate a new secret, let's say you feel like yours has been compromised or whatever, it's been sitting out for a long time or whatever, you can usually regenerate your client ID, your client secret. But that's all the control you have over it. And like I said, it's usually like a 40 random characters, so it's really secure. Okay, good stuff. Thanks, guys. And this is the most important grant type, so it's totally cool spending time on it. This is the most common one. I don't know any OAuth server that doesn't support this.
So I have another question too.
Yep.
I think, and maybe I'm mistaking which part in the process this takes place, but I believe that Facebook and Twitter also require the host to reverse resolve correctly for
yes.
that token to work. So you can't use that client ID unless you're using it in connection with that domain,
yep.
which is resolving correctly.
Yes, and I have some slides for that at the very end because I wanted to get through all the grant types. But just to reiterate what he's saying, basically, whenever you create your app, whenever you set that up, you're asked to establish what URL you'll be making requests on and ahead of time, right? So remember, let's go back. Whenever it sends you back here, you're supposed to say that this URL is what you're going to be using for this client. And then whenever you make this request here, you actually include that URL with the request. And this is just a way to make sure that no one's tampered with it, no one's been able to redirect the user to their site and then to your site. There's a couple of other parameters that are associated with locking this down. There's another parameter called state, which is basically a forgery prevention token, and it's similar to a CSRF that you would have in a form, which is basically it maintains the session of the user, so you know that some other user didn't tamper with the session. All those things are kind of more implementation detail. They're all part of the spec, so you'll see those around on most of these calls. But this is the basic, nature of these workflows. So, is everyone okay with me continuing on? Cool. So the next grant type is actually the same one. It's just for devices. So I mentioned that the token is received whenever you exchange your client credentials and the authorization code with the token endpoint. But if you are on a mobile application, you can't really put your client credentials here because someone's going to just bust open that binary. They're going to find a way to pull out those credentials, and then they'll be masquerading as you. So this is an example of when this grant type is in use. Is if you are on a native application, something on a desktop, something on your phone or tablet. Or even if there's like a JavaScript-based app where all the code is in JavaScript. And so once again, they can't really have their credentials there. I have this guy here because it's still three-legged. We're talking about three parties involved. And that's basically everything I said. And we still need to validate that, the device that we're calling from is indeed valid. And this is basically how this flow works. We're skipping this token step here because we can't really authorize with this token. What we can do is register this callback to be associated with our client in a way that we can reliably transfer an access token directly. So what happens is the user will end up authorizing in some way, and then once they approve it from there, the authorization server skips the whole authorization code step and just sends them back with an access token. So what this looks like is it takes several different forms. This is the official spec form. These are other ways that I've seen it take place that aren't part of the spec, but also seem like it's in the spirit of the spec, and so I don't really have a problem with it. All of these would have to use web views otherwise, which is kind of annoying. So they've done other things to make it a better user experience. But in this case, you send it back with the fragment. Fragments aren't sent to the server, so it's just a security precaution. And this here would be, say, the URL for a JavaScript application. One thing Google does, which is pretty cool, is they just pass you a JSON object with all the parameters. and you register your origins URL, which is basically like, this is running on mydomain.com, or star. Actually, you can't even do wildcards, so you have to specify subdomains or whatever else. And then if you've ever built iOS and Android apps, I haven't, but my understanding is you would receive some sort of bundle ID, which your platform can then securely associate with a running application, and then these authorization servers would issue a request containing the access token directly to those applications using underlying SDKs. So, to be honest, my understanding of this is about that, but I'll try to answer any questions if anyone has them. Cool, awesome. So, one more little thing about OAuth in the intermediate area is, I'm sure you guys have seen this button, but instead of OAuth, it'll say Facebook, or it'll say Twitter. This is my friend's website, kmplabs.com, and they have every single possible option offered on the web, apparently, to log in. So if you've seen this, you might not really know what this is. This is actually just authorization code. And there's nothing special happening here. It looks a little different than maybe if you're authorizing or if you're linking an account or whatever else. But all this is doing is sending you through the same authorization flow. And then once you come back, they're making a call to their APIs to some profile endpoint to get some information about you that they tie then to a local account. So if that didn't make sense, I'll just go back to our flows here. Once they get this access token, so all this is the same that we've talked about. Once they get this access token, they make a call to, let's say it's /profile. It's something that says, you send us an access token, we'll give you a bunch of that user's information. And then what they get back would be, say, a user ID, that this is a Facebook user ID. This is some sort of unique identifier that they can then map in their database to a user account on their side. And then they'll have whatever other information about that user they can store in their own database to make your profile automatically set up. But I say it's a trick just because I don't know if you guys have ever done that, and then it's like, now enter a password, and I'm like, why did I log in with Facebook if you just made me create my own password afterwards? It doesn't make any sense.
So you don't have to take your email address down.
I mean, I think you still do, though, right? I mean, if they have their email address, they'll just create an account off of that. So I don't know. It's not SSO. SSO is something completely different. That's, if you log out of one application, you're logged out of all the other ones. I've tested this out, If you log in, I don't know if you guys use Travis CI and GitHub, but that's a service that offers this. That's really popular. You can log out of GitHub. You'll still be logged into Travis CI. They're maintaining their own session. It's a very different. It's fundamentally different, even though it kind of looks similar on the outside. This is actually really good for your application. It's a great way to trick them into creating an account on your website. Obviously, it lowers the barrier of entry, which is nice. And if you're a server, it helps you keep a canonical user base. So it's actually pretty cool. It's a nice trick. And it's standardized in something called OpenID Connect, which if we have time, we'll talk about.
From a user perspective, how do you know that they're not phishing?
How do you know they're not phishing?
Just trying to steal your username and password for Google.
So you don't get, the reason why that's a great flow, and I call it a trick, but I think it's totally fine, is it uses the authorization code flow so they never get your username or password. The only thing they get is what these APIs expose. And these APIs, wrong slide. These APIs will never expose your username and password in some profile call, right? I mean, they might expose your username, but.
Some people may create an account with their same password they use on Google or whatever, and they're asked to create it.
Well, it's logging onto the website directly, so
Yeah.
you're not giving it to that client.
So in this call here, you are only signing in to, let's say, Facebook. Let's say we're on this slide here, and you click this button, right? We'll just walk through it. So you are not asked for your password until you reach the actual Facebook.com website. So this would be if you created your own account. So it's hilarious because there's like 5 different possible actions here, which I think is funny. So you can either create your own profile directly, or you can use these other services to log in and do it automatically. So, all right. So this is the most boring of all grant types. It's called refresh token. If a user does all that stuff, authorizes your application, gets redirected all over the place, you probably don't want to do it to them too many times. They'll get cranky. So refresh tokens often don't expire. In Facebook, they don't expire, which is why you can log in and see some app that's authorized from like 5 years ago. And you're like, I don't remember this guy. And it even will tell you like, yeah, this hasn't made any calls in forever. But it still has the ability to, because they're sitting on a refresh token, which allows them to pull an access token whenever they need to. So oftentimes these do expire. It just depends. And when they expire, then you have to send your user through that whole authorization code flow again. But refresh tokens are basically just a nice way to save you and your user from the headache of going through the flow again. And what this looks like is in the initial token grant, along with all the other parameters we've been talking about this whole time, you will receive a refresh token as well that will look very similar to the access token. And when you're ready to get a new token, because your old one expired or for whatever other reason, you can make a call. Again, it looks very similar to all the other calls we've made to get a token, where you stick the refresh token in the request body with, again, this is optional, but the spec asks you to always say what grant type it is. And then if it's still valid, you'll get back an access token.
Were you saying that you always receive the refresh token with the access token when you first right there? Is that a standard?
Yes. If the server supports refresh tokens, you will almost certainly receive one. Only for the access token flow, though. Implicit client credentials, user credentials, all these other flows, no refresh token. You'll only receive it for an access token flow. I could explain why. It's not really that interesting. But yeah. If you don't get a refresh token, first thing I would do is look in the documentation to see maybe they require a certain query string parameter. Again, because OAuth2 is a framework rather than a protocol, some of these things are defined differently per application. So a lot of the process of implementing against these APIs is going to involve going to the documentation. So if they don't send one in automatically, I'd take a look. It's possible they don't support one. It's not required to support one, so they just might not. All right, that's it. So we have not very long to get through the advanced tier, which is totally fine. I might just ask, has anyone here heard of JWT? Cool, we got a couple of people. I'm just going to go...
Java thing?
Java, yeah, it's not a Java thing. It's JSON Web Token is what it stands for. Or we could use 5 minutes for questions. Let me just explain what JWT is super quick, and then we'll call it a day. Or does anyone care about OpenID Connect? Cool. All right. Well, it's not that important, to be honest.
Okay, then I don't care.
It's just fun. So I think JWT is really cool, so I'm going to explain it. JWT stands for JSON Web Token. This comes up in a couple of different places. It comes up in Google's APIs. And if you've ever created any applications to interface with Google+, you might see something that says service account. You create a client ID. It has this button that says generate new key, and basically all that does is download a private key onto your computer. And if you ever create one, you're like, what just downloaded? I don't understand. So basically what this is it uses public private key encryption. It's not really encryption, it's just signing of a payload. And the payload that you're sending in is a JSON Web Token. That's basically just the syntax used to send in the data for what you're wanting to receive back from the server. So this is very enterprisey. It's actually really cool. I don't know if anyone here has any reason to use this ever. But just in case, I want to explain the very basics in the next 1 minute. So basically all you do is you have 3 parts to this thing called a JWT. You have a header, a payload, and a signature. So the header basically has metadata on what you're sending in, so an algorithm for what you're using to sign it, and the type is there for whatever reason. And then your payload's really the juicy, meaty stuff, which is like who I am is issuer, so that's the client ID. Sub is subject, which is who you want this token to be used for. And audience is usually the server that you're sending this into. So, it's, again, just another check to make sure that this is for the right party. And once you have these, sorry, this is PHP, by the way. I hope that doesn't make anyone's eyes bleed. But
just a little bit.
Yeah, I understand. If I had more time with these slides, I'd change it. So Json Encode you basically turn it into a JSON string, whatever, right? And then you base64 encode it, so it looks something like this. And then your next half, you do the same thing, so it looks something like that. And then you can concatenate the two together with a period. So you'll see this first half is a header, the second half is the payload. Linux has support for this on the platform. Every single language has their own functions as well. So you use some sort of signing function to generate a signature, and then you add that on the end with a period as well. So you end up with a string with 2 dots in it, and then you send that in to the token endpoint. And if this is valid, they have your public key, so they can validate it. And for those not super familiar with how signatures work, this is basically able for anyone can read this. The base64 encoded stuff is not encrypted at all. It's just a format that makes it URL safe. And the signature basically just allows anybody to say they know where this is coming from. Anyone with the public key, and you can pass that out to whoever you want. You're the one with the private key. That's the thing that can't go out to anyone else. So you as the client sign this thing, you send it out to the token server, and it says, oh yeah, this is totally from the client, and they'll send you back a token with the depending on what you requested in this slide here. So it's an example of layering security, right? If anyone captures this token, they can't really do anything with it because they can't, even if they have your client ID or whatever, they can't sign a payload to send it in. The validation will fail. So, and then to piggyback on that, you can actually have the same syntax, but you can return it from your server. So this is something we're doing at Adobe, which I think is cool in different places in the business, which is now you'll see the 2 periods in the access token we return. And so this is cool because you as a client now have all the information associated with this token right here. You just need to base64 decode it, and it's right there, and you can parse it and everything else. The other thing that's cool about this is we as a API server don't need to store this anywhere. We signed it with our own private key, and as long as we have a public key for that private key, we can verify that this is valid and that it came from us. And we don't need to put it in a database. And more so, we don't need to put any of the information that it's associated with in a database because it's all right there. So I don't know how useful that is. I just thought it was really cool. I'm going to end with that. And before I open up to questions real quick, I'm just going to put up this slide, which is basically this kmpuniversity.com/screencast/OAuth is a great screencast for learning how to use OAuth. They do walkthrough examples and code and good stuff. This is my GitHub library if you want to check it out. The specs are they make for great fun reading. And joined in is my talk, and I'd love some feedback on that. So that's all I have, and I'll open up for questions.
We've got 2 minutes for questions. You said JWT was similar to OAuth1. Which one do you prefer, OAuth1 or OAuth2?
Well, I'll come clean and say I've read the OAuth1 spec briefly, and that's the only experience I have with it. I understand that OAuth1 uses something similar in the sense that it involves signing the tokens. And I think I said similar because that's pretty much the only way it's similar. Also, both of them have nonces. Both of them have created at timestamps to prevent replay attacks. Those are optional in JWT, but they still exist in the spec. So it's similar in that regard. They're not substitutable for each other by any means. So, yeah.
Can you recommend any good books on OAuth?
The spec is honestly, I would read the spec. I don't know of any. My library was implemented in a book, but after reviewing the chapter, I would not recommend it. So, yeah, there may be something out there. I'm not sure. Cool. Thank you, everybody, for coming.